Hi everyone, Jason here with the Do You Know Drones podcast, and today we're going to be talking about how to use the new DJI Mavic 3 Enterprise and a single ground control point, Propeller Aeropoint 2, to create survey-grade data. Let's get started. Thanks for joining me on this journey. We're going to be doing a full end-to-end detailed workflow of how to use this equipment to create survey-grade data. So we're going to go through all of it. And this is going to be a rather long video, but I'm going to put down in the description all of the timestamps for each individual step of the process. So that'll allow you to, as you're working through it yourself, you can go back to this video and you can just move on to the next step. So let's kick this off with a small explainer cartoon video that I hope you enjoy that explains the differences between RTK and PPK. Meet Jack and Jill, two surveyors trying to map out this large field. Jack is using PPK, while Jill is using RTK. What do these acronyms mean? RTK stands for Real-Time Kinematic. It's a technique that uses a base station and a rover to provide centimeter level accuracy in real time. With RTK, Jill can see her location on her receiver with high accuracy. PPK stands for Post-Process Kinematic. It uses the GPS data collected on site and processes it later in the office to achieve high accuracy. Jack can collect data in areas with poor signals and process it later when he has a stronger signal. RTK requires a base station with a known location to send correction signals to the rover in real time, allowing for high accuracy measurements. PPK requires the GPS data collected on site to be post-processed with the base station data to achieve high accuracy. Both techniques have their advantages and disadvantages. It's important to choose the right one for the job. And we're back. I hope you liked that little cartoon. It might have been a little corny, but hopefully you found it educational. So let's talk about step one, mission planning. Mission planning has three parts to it for this particular mission. One is finding a local base station. Two, making sure that we have access to the RTK network we're going to be using for the mission. And three is site planning to making sure we know the airspace and everything around where we're going to be flying the mission. So let's get started. All right, so the first step that we're going to take is we're actually going to find a reference base station. Luckily for us, we have the continually operating reference station or core stations that are available to us in lieu of having a base station on site. So we're going to go ahead and just search for Core's map, and we're going to see where these core stations are. So there are core stations all over the place. If we zoom in to where we are in Colorado, you can see that there are several. So what we're going to do is we're going to look in this area here, and we're going to find a core station that works where we are. So one thing that's not on this map that could be helpful is to see essentially how far, what is a 15 kilometer radius, and why is 15 kilometers important? Because we want to be within 15 kilometers of a reference station, simply because whether you have your own base station, reference station that you're putting on site, or you're using one of these core stations, you want to be within 15 kilometers of that because that's very important for the GPS correction. They need to be close together on the surface of the Earth so they're seeing the same satellites over the same period of time so that they're getting the same correction. And there's more to it than that, but we'll just stay from there. So let's go ahead. I kind of like this one up here as ZDV1, being that we're doing a drone video, being close to an FAA site for GPS. That is great. I can pull up the site info. We're going to use this here in just a little bit. But what I'm going to do first is I'm just going to pull up a map. Let's pull up a map of these in Google Earth. So you can download these as a KML and you can view them in Google Earth. And I've already sort of went through and took a look at what these stations look like with a 15 kilometer buffer. So this is what a 15 kilometer buffer looks around here. So I'm going to be looking for a site within any of these rings. Right now, I kind of like this one the best. Longmont's a good town. There's a good place I can grab lunch. So I'm going to go and look within a 15 kilometer radius of this Longmont. It's not too far from home. It's away from, it's well within Class 2 airspace. There's much more Class 2 airspace up there than the other two. So I'll likely use this course station as my reference. The next step is I'm going to see, what can make my life a little easier? So I'm going to be bringing the Propeller Aeropoint with me, but I also can be using some existing survey benchmarks that I can use for this. So I'm going to actually look to see if there are any existing survey benchmarks within this area. Luckily, the resource is the National Geodetic Survey. So the National Geodetic Survey has these survey benchmarks, and I use their Survey Data Explorer to access them. And what I'm gonna do is I'm gonna go to the same area. I'm just gonna zoom in until I see Longmont. I'm going to right click and I'm going to place an X. That's gonna show me all of these different control types, GPS sites, course sites, all of that's gonna be within this area. So I can zoom in and see what I'm actually looking for. So let me just go to the map layers real quick. And if I take a look, I have a few different options. I'm actually looking for the symbols that are complete symbols like this. The ones that have the GPS and vertical control. So I want horizontal and vertical control. So I'm gonna look in these areas and see if I can find one that works for me. I'm gonna have to cross-reference a few different things. You're gonna have to cross-reference the Lance map, and you're gonna have to cross-reference where the core station is, and cross-reference where some existing survey control. Now this is not required. I'm using this so I can find out where it is. It looks like there's a good one right here. I can pull up the data sheet. And what's cool about this is actually gonna give me all the information that I need for later in the video. So all of this information, we're not gonna dive into it now. It gives me everything I need to know about it. It gives me its designation, where it is, the state, county. And it also gives me, here's fun, it gives me photographs. It actually shows me where this point is. It's sort of blocked out the person, but it's on a survey marker along a fence line, and this is obviously a large aerial control that they're using for this. But I can go back and I can actually take a look. Here's what the station looks like. It's a set monument inside covered access. It has the township range information, its designation, and some other, it says it's a vertical control mark, but it's obviously also a horizontal control. So this is spot on, millimeter accurate. And you can check that here. You can see what the particular accuracy of these sites are here over time, how you locate them, when they've been recovered. People have found them over time. You can see the recover history when it was monumented in 1984, all the way access 2010, and I obviously am going to access it for this. You can see that the standard deviation, these are in centimeters, less than a centimeter, and for northern and eastern, or X and Y, or latitude, longitude, and a little bit more than a centimeter standard deviation height in. So you can see this is a very good vertical and horizontal control. So we're going to be using this for our secondary checkpoint. The next thing that we're gonna have to do is we're gonna have to find an RTK station. How do we find an RTK service that we use for this? So I'm actually gonna Google free N-Trip RTK. Now this is gonna be really interesting because there's gonna be several that you can take a look at, but I'm gonna use this North America N-Trip list. It's gonna give me all of the N-Trip casters and RTK service providers that are active in North America. So there are several that are global, some that are in Canada, some in the United States. You can see that popular players like Hexagon, Trimble, Topcon all have paid services. Let's try one of these free services. So let's go ahead and I'm gonna try RTK to go. It's a community, and I like that since it's people that are putting up these sites and maintaining them, but they're still survey grade and professional grade information. So let's click this link, and it's gonna take us to the front page of RTK to go. Well, I'm gonna skip it. I'm gonna go like, how do you connect? How do you connect to RTK? We're gonna be using the network RTK connection on the Mavic controller. So how do we use that? So some piece of information that I'm gonna need is I'm gonna need to know this information right here. This is if it can't resolve a DNS name, you can use this RTK to go in this port, and you'll need a mount point. We'll talk about that in a second. But I'm gonna go ahead and use this information. It has an IP address and it has a port. So I'm gonna need a port plus a mount point, and that's gonna give me everything that I need. So what's interesting is you can see you're gonna find a mount point that you want, and this case is gonna be somewhere fairly close to us. For the user account, we're gonna enter our email, and for password, if it requires one, we're gonna enter none. So our software does need a password, so we're just gonna put in none. So we'll get into that here in just a little bit. So, but where are these things? Can I see a map of where they are? So if I click on this, it'll take me to the full list. Okay, well that's helpful. Well, let's go ahead and view all. This is kind of a messy map, but let's zoom into our area here in Colorado. And you can see that we have two RTK casters within our area of where we're going to be doing. We have Boulder Spark Fun, and we have Berthoud, Colorado. Let's go ahead and let's choose this Berthoud, Colorado. So what we're gonna do to find Berthoud, Colorado is I'm gonna go back to this list. So I'm gonna hit back. I now know this is very close to where I want to be. I could use either one of these. Since it's network RTK, I probably wouldn't want to use something in another state, but using something within your state, and most states, just so you know, have a very good free network RTK solution that's available to you. Colorado has some, and there's some other ones that are on this list. I know UNAVCO has several more sites, and that's also free. So really, your mileage will vary depending on what state you are. Colorado has some pretty decent coverage, but some other states, especially on the East Coast, have fantastic coverage. Texas, Minnesota, California. I mean, there's a lot of states that have wonderful free network RTK coverage from these end-trip casters. If I want to take a look at sort of the status of that, I can scroll down to Berthoud, Colorado. It's currently up. You could see its uptime. You could see the version of RTCM, how much data has been recorded. I can click into this and get further information on what's there, the receiver firmware. There's just a lot of information that's right here. We won't need most of it. One thing that's interesting to note is that it is accepting signals from all GNSS satellites, not just GPS. There's many constellations: GLONASS, Galileo, Beidou, WASPnet. Like, there's so many that are managed by other countries, and all of those are available for corrections, and they're all being recorded by this antenna, this caster. So they're providing corrections for all of those satellites, which is important. So let's go ahead so we're going to use this information. Like I said, the only thing that we need here is basically this mount point. That's the only information that we're going to use, plus how to access it, which we've already covered. Okay, so we now narrowed down that we want to use this ZDV1 core station. We also want to use that Berthoud, Colorado end-trip caster, which is up here in Berthoud. We're going to find a site that's adjacent to both of them to fly at, that's accessible, that's easy to fly at. So I like to use Aloft Air Control for pre-mission planning. So it's going to pull up sort of where I am, but I'm also going to sort of pull up, I want to zoom towards, here's Longmont. Here is that lake. If I put, this is where the core station was. This is where the point was along this Ute Highway. So if I click in here, really this is all Class G airspace. Everything's great. I can request a mission here. There's no LANs required. The skies are fairly open. It's very accessible along this highway. It's pretty easy to get to. So I'm gonna actually choose a location right along here. So let's go ahead and let's plan that mission. So the mission that I planned along here is literally right here at this Agricultural Heritage Center. So I planned this for a 4-hour duration. The only things that were there in the summary is Vance Brand, which we talked about, is about 2.5 miles to the south, and Longmont United Hospital is about 2.3 miles also to the south. So this is the only information. It's all Class G airspace. It's wide open. It's clear. This is where we're going to be able to include the Propeller Aeropoint over on this side of the map. We're going to have an existing NGS survey benchmark on this side of the map. Those are going to be our 2 checkpoints for our survey once we get onto the field. So let's go ahead and head out to the field now, and we are going to fly this mission. But the first stop we're going to make is at this NGS benchmark to set our checkpoints.
So this is a National Geodetic survey marker. If we come down to the bottom, we can actually see that there is a cap here. There's a covered access, and within this access, there is the ground control point. So we're actually gonna set our ground control point right here on this spot. We're gonna clear a little bit out, and we're gonna set it here. And then this is gonna be used as a checkpoint for our survey. All right, so we went ahead and set our ground control point, and go ahead and put it down right here at the survey marker. We've double checked that it is right over the survey marker.
All right, so here we are in Longmont at the Agricultural Heritage Center to do our test flight using the Propeller ground control point and the Mavic 3 Enterprise RTK. So we have everything set up. We've been through everything that we've already done in the office, and now it's time to actually do the flight. We've made all of our checks. We're in Class G airspace. It's time to get going. So we already hit the 1 button on the Propeller Aeropoint 2 to get it logging. So it's gonna log for the whole duration of our flight, and it's recommended for at least 10 minutes. We're gonna probably let it go for 20 minutes today just to make sure that we're good to go. The base station, the core station that we're using is actually just adjacent to us, a few miles south. It's like I said, remember, it's important to be within a 15-kilometer radius, so we're just a few kilometers north of ZDV, which is the Denver ARTCC, or the Air Route Traffic Control Center. They do the high altitude and IFR routes for this region. So there's one of 22 centers. We're just a few miles north of this one. Just in case, just a little helpful tip, if we have a flyaway, that's the ARTCC that we're gonna be calling to let them know that we had a flyaway. Not anticipating that today, but just in case, it's good to have it on the checklist. It's good to have that number handy. So let's get going.
One thing that I missed showing you on video out in the field was me pushing the single button on the Aeropoint, on the Propeller Aeropoint too. So let's just do it right here, and you can see just how easy this is. So here's the Propeller Aeropoint. It has a solar panel. It's the Aeropoint 2. Here's the button up here that you got to push. And once you push the button, you can see that it starts logging. And then when you're done logging, you're going to push the button, and it's going to go to network until it finds your network. There you go, until it finds your network, and then it will upload. Once it finds your network, it will go ahead and upload those corrections to Propeller for, it'll upload, see it's uploading right now, it's a solid green, so it'll upload them now, and then it'll turn itself off, and it'll be ready to go. So let's pick up from there. That's as easy it is in the field, as easy as I did it right here. You place it in a location, you push the button. When you're done with the occupation, you push the button again, you bring it into the office, it automatically finds your network and uploads to the Propeller network. It really doesn't get much easier than that. All right, so we switched over to the controller, and now we need to make sure it's connected to Wi-Fi so we can receive those network connections. Once we have the connection, we can switch back to the DJI Pilot 2 app. We can see RTK is not connected, but if we go into the camera view and go to RTK, this is where we set our custom RTK information. We save it, then we put the information that we received earlier in the video, and we can see that we are now connected. You can notice positioning is single, right? Positioning is single. We have to wait till it goes to fix. There, it just went to fix. RTK is connected.
Updated. Check map to confirm.
Home point will be updated, and then we're good to go. You can see that we have a good signal strength, the standard deviation. Those are in feet, so less than 1/10 of a foot, X, Y, and Z. So this is now pretty much good to go. So now what we're gonna do is let's go ahead and plan let's plan the mission right here. We'll just go through that workflow, create a review, it's mapping. It's gonna bring us right to this location. And what we're gonna do is we're gonna go ahead and tap to create a mapping area. Give it a name. Just call this one AHC for Agricultural Heritage Center. You select the camera. This is the Mavic 3E wide camera. Here we're gonna set the speed. So we're gonna set the speed down to 15 miles per hour. Why are we setting it to 15 miles per hour? I want it to be able to maintain that network connection for as strongly as possible. So slowing that down basically maintains that connection better. And that's important for us. You can see the rest of the advanced settings here. We're gonna leave it at 70, 80, 70 side, 80 frontal. Let's go ahead and put this boundaries where we want them. Right now this isn't where we want it, so let's stretch it out. Make sure we're getting that checkpoint over just north of Ute Highway. Let's stretch it down to the southwest. Let's go to the northwest. Great. And bound to the southeast to square this off. Set the flight altitude to 300 feet. Everything else looks good. So with this new firmware, you have to touch and hold the play button next to the mission to get into the pre-flight check. So you can notice here, everything looks normal. Here you can see RTK is connected. That's important for this mission, obviously. Then you click Upload Flight Mission and Start. And then you'll be ready to go.
Moving to start point.
All right, so before we shut it down, we're gonna let it log the RTK just for a little while longer. I let it run for about 5 minutes after landing. You can do this at altitude if you wanna hold, or you could do it on the ground as well. Just give it a few minutes after you land, a few minutes before you land. Time is your friend in these type of operations when you're using GPS correction. So the longer you have it sit, the better your solution will be. So just a quick note, so we're just gonna let it sit and then we're gonna head back into the office and we'll meet you there.
Okay, so we just came back from the field. What do we do next? So now that I'm back in the office, I'm gonna take the Mavic 3. I'm going to, let's take the battery out. That makes it a little bit easier to access the drive, access the SD card. I can just take the SD card out, set the drone aside, put the SD card in my handy dandy reader, and let's talk about what we do next. All right, so the SD card is now in the computer. You can see it pulled it up automatically. The first step that I like to do is I like to just grab the data that I'm using. And here's something really, really neat is DJI Pilot 2 actually, when you do a mapping mission, it takes all of that data and it puts it in this folder. So I'm actually gonna cut this folder from here and I'm going to put it into a new folder. And I'm just gonna go ahead and just put it, create a new folder right here. And we're just gonna call this AHC PPK. So we're gonna paste it here. All right, now that the data's there, let's go ahead and take a look at it. So if we open up the folder, you'll notice there are a few new files. So now these files have to do with the RTK. So these are the observations and the nav file and the timestamp mark files that you will need for the RTK and PPK process. So it's all here, all the images are here, and these 4 files are here and we're gonna need those. So let's go ahead and see. So the very first step, right? You can upload these files directly to your favorite processing data. You could do it in Pix4D, you could do it in DroneDeploy, you could do it in Hammer missions, you could whatever, measure ground control, whatever works for you. You know, Agisoft, whatever tool you want to use, totally fine. Most of them will all use this data the way that they are. So for this purpose of this video, I'm going to use DroneDeploy just to showcase how that particular workflow. The workflow won't change necessarily depending on what process you're using, but I'm gonna go ahead and just use DroneDeploy. So I can take this data, hit the upload button, and I can just take that whole folder. Remember, here's this folder again. I can take this whole folder and just drag it and drop right there. That's one thing that I kind of like about DroneDeploy. It makes it pretty easy to do. It's gonna automatically sift, sort. Now remember, it's got 492 photos. It was captured today, just a few hours ago, and I'm gonna call this one RTK. So now we haven't been through the PPK process, so this is RTK only. But I'm gonna create one project just with the RTK data, just the way that it is. So we're gonna go ahead and hit start on this. We're gonna keep this Natty 3 2011. That's gonna be important later. Let's give it a project name. Let's call this AHC PPK and start uploading. So now this is gonna automatically upload the data. And while we're doing this, waiting for this upload, we're gonna go ahead and go through the PPK processing so that we can upload the PPK corrected data as well. And then we can compare and contrast. All right, while we're waiting for the RTK data to upload, let's go ahead and jump into PPK processing. All right, one thing that I always check first is sort of data availability. Now, unlike RTK, which is real time, PPK can sometimes, if you're using a correction network like Core Station, it can take a day. So as you can see, remember we were on day 62, this data is not available yet. So we have to wait till tomorrow. So we're gonna come back tomorrow and we'll do the PPK processing. But I always check this. Sometimes, depending on where you are in the day, you can get it a little bit earlier. Sometimes it takes a couple days. So I always check this to see where that data is. So here, right now, we can't process this data immediately as we get down. So PPK processing can happen the next day if you're using Core Station. So we'll come back tomorrow and we'll pick it up again. Well, let's cover the Propeller Aeropoint processing. This is the ONE GCP that we're using for this, and as you'll see later, we're using it in a sort of untraditional way. This is really, really simple to use. The Aeropoint is literally a single button setup. We showed you in the field. When you push the button again, it starts searching for the network. When I came home, it automatically found my Wi-Fi and uploaded this Longmont point to their server. So the thing that it asks for at this point is it wants you to process now. So we haven't done that yet, so we're going to hit process now. We're going to use it gives you a little note to where this is. This is approximately where we were in the area. We're going to use, you can give you lots of different options. Propeller correction network is what we're going to use. There's a lot of different, obviously there's a lot of overlap here, a lot of areas where they're going to connect from. It's going to produce coordinates. Remember, this was important in NAT83 2011 geographic coordinate system. You can use a global survey benchmark. We're not going to use a specific benchmark for this one. You can use a local site survey benchmark. You can upload Rhinex. Or you can leave it unreferenced as the approximate point. So we're not going to do that. We're just going to use a propeller correction network and hit process. At this point, it's going to go back. It's going to wait for correction data. They're going to process it, QA/QC it, and they're going to upload the points to the end. But you can see that when this is done, we're going to have a bunch of information that we're going to be able to use and download for our checks. All right, so we are back a few days later, and we're just going to check the data availability for that ZDV1 NGS course site. So if we take a look at the GPS start date, we can see we flew this on Friday. That's day 62. And if we take a look at the map, if we take a look at the data availability for ZDV1, you can see that 62 is available, so that's great news. But 63, 64, 65 are not. So sometimes, like I said, it could take a few days for everything to catch up. Luckily, 62 is available, so we can download that data. So if I go to the custom files over here, we're going to hit the start date. That's going to be day 62. We're going to look at a start time. Now this is in GMT, but you can also select this for Mountain Time, GMT -7, and you just need to know when you started. So in this particular case, we actually started collecting at about, in GMT time, in Greenwich Mean Time, UTC time, we actually started collecting right around 1828. So, and I'll show you where to check that here in just a minute. So that's actually, we're going to download everything from 1700, and we're going to go for 3 hours. So that'll cover the time that we were flying. We were done flying at 1854 GMT or UTC. So 3 hours past that will give us enough time that we can download the orbits, we can download a coordinate file, we can download the data sheet. In this case, we're just going to download, so we're going to pick a course site. In this case, you can actually start typing ZD, and you can just go to ZDV1. We're going to download all signals, and we're going to get course data. This will just take a moment because the data is available. It'll come up with a download. So you can download this data, save it. You can extract it. So it's a pretty small file. Here's what comes in it. You've got a README, a log file, a nav file, and an observation file. So we're going to extract this data. There we go. And we're going to use this in our RTK post-processing, and we're going to switch to that next. So stay tuned. Okay, so for the RTK post-processing, we're using a tool by TopoDrone. Now this is a fairly inexpensive tool that allows you to do PPK post-processing, RTK post-processing, static, precise point positioning or PPP, and also that has a suite of sort of LiDAR tools as add-ons. This is just sort of, it puts in a lot of great tools all together. It also gives you some great tools for looking at the GNSS data archive, doing calculations, converting data, all types of different things you can do. You can trim your IMU and track file if you're using LiDAR, and it also has a LiDAR cloud viewer. So in this case, we're actually going to be using RTK post-processing. And step one, we're just going to go in these steps in order. You're going to select the folder where the files were. So we're going to go ahead and come to this folder. We're just going to click on the DJI folder that has the files, select the folder, and it's going to automatically pull in the survey location and all of the images. So there you go. It's gonna pull in the images to take a look at that. You can see the information, number of events 492, red tags 492. It's important that those two match. Here are the time of the first and last observations in UTC time. That's where I got the times in the previous section here. And I can double check them here, so that's great. We're gonna keep everything the same. We're gonna select the navigation file. The navigation file is not gonna be from the drone folder. We're gonna select it from the base station. So there's two files, remember, that came with this. Remember the ZDV1? Where there's the nav file. We're gonna use this 23N nav file. And we're gonna select the observation file, automatically knows it. Here's the same observation file, 23 Oscar, open. And it's gonna pull in the location. Here's the base station location. Here's our survey location. And from here, it's pretty simple. We're just going to go ahead and hit start. Now this is gonna open a series of windows. I'm gonna drag them over here so you can see what's actually happening. But you can see, if I hit start, it's going to go ahead and do some calculations. And this is the one that I want to show you. This is processing the data. So Q equals 1, that's the highest level of RTK quality available. You can have Q2, Q3, Q5. Q1's the best you can get. It may occasionally get to Q2. And this is a function of the distance from the base station, your survey distance from the base station. In this case, we were pretty darn close. So I was expecting Q1. So now this is doing forward and backward continuous calculations from the observation files in a post-processing algorithm. So what it's doing now is it's now writing the new coordinate tags to the photos and putting them into the output folder. So up here, you can see that it created its own output folder, and it's going to be basically a subfolder of the drone folder. And it's creating that now. So you can see that it's doing this for each individual photo. I'll come back when this is done because it's going to do it for all 492 photos. Okay, so now these are all done and they're waiting now with the new photos, the corrected photos, the PPK post-processed photos are now ready to upload to DroneDeploy. All right, jumping back to DroneDeploy, we're gonna go ahead and go to the uploader and we're gonna choose the files. Let's bring up the files here. And if we go back into the folder that we created, so here's the DJI folder. You can see there's a new output folder. In this output folder, you're going to have this folder called Update Tags. And this now has all of the photos with the updated tags. So we're just going to, we can go back a level and just take Update Tags, drag and drop into the DroneDeploy uploader. And just like before, it's going to sift and sort. And we're going to call this PPK. And we're going to start the upload. In this case, I've already done the upload, so you can just see that. I just want to show you that particular folder that you're going to be grabbing from after you've done the RTK post-processing. Okay, but before we jump back into DroneDeploy to see how the RTK and PPK orthos have processed, let's go ahead and download the processed Propeller Aeropoint data. So I got an email saying that the propeller network correction was complete. It only took a few minutes, honestly. You should be able to download it. You can check some things right here. You can check coordinate systems, the EPSG codes. You can see the timeline, how long it was processing for. You can see that the duration or the dwell time or the capture time there. We can see all of the coordinates, and we'll use these here in just a few minutes. And you can see the quality. So it took 532 points. It used all of them. The baseline distance from here to the network correction station was 3.25 kilometers, well within the 15 kilometers. So the data variance is very, very low. We're talking millimeters. So single millimeters, 8.3 millimeters in the Z. So this is a high quality point. And what we're going to do is we're going to download the CSV. You can download a PDF, a KML, a CSV simple, which just has the the northing and easting information, so it's going to use the output coordinate system here. So this is in US survey feed and nav D88 geoid. But we're going to go ahead and just do the whole CSV, and we're just going to save it. And let's open it. We can explore it just real quick. Take a look at it. Here is the information, dwell time, the geographic coordinate system, which is what we're going to be using, the projected coordinate system, the vertical coordinate system, nav D88. We'll be using these as well. And then here's all the information on the points. So we're going to be using latitude, longitude, or the northing and easting information. So let's go ahead and use that. You can see the variances. All the information is right here as well. But let's dive back in to DroneDeploy and see how we actually use this. So let's just take a look at this data just real quick. I now have this up. I can see that I've got the two different collects, RTK and PPK. They're both on the same date. If I scroll between them, there doesn't look to be a huge difference. But let's go and just zoom in to our Aeropoint real quick. As much as this will let us zoom in and this, hit the compare button, and you'll notice I can slide back and forth, and you can see that actually the point is moving, right? So RTK is on this side, PPK is on the right side. So you can see that it has shifted, right? So it shifted between RTK and PPK. What's that distance? Well, let's just show you a neat thing. So even with this tool open, I can still do a distance measurement. So I can click center here, move it back over, and click the center here, and then end it. And it'll give me an annotation. It'll tell me about how far. So it's about 2.5 feet difference between the RTK and PPK for the Aeropoint location. So that's not a huge distance, but it's still not quite survey grade, right? So let's go ahead and take a look. I've now downloaded both of these. Unfortunately, DroneDeploy doesn't have a very good upload mechanism for point data. They let you do for polygons and let you do for polylines, but they don't have for point data yet. So I went ahead and downloaded both orthomosaics into ArcMap or ArcGIS Pro. So I have both maps here. I've got the PPK and the RTK. Notice the small shift between them. Let's go in and just take a look at the data for the Aeropoint. So if I scroll into the Aeropoint, I can really scroll in beyond the resolution here. Let's just go right here. And what I'm going to do is I'm going to actually use the information from the Aeropoint page. So I have latitude and longitude in degrees, minutes, seconds. And I'm going to take it. So here's that information. I've got latitude, I've got longitude. It's in NAT 83 2011, so everything matches. That's what's important. Everything's got to match. So I'm going to copy latitude, put it in the latitude column. Actually, this is decimal degrees. That's my fault. Decimal degrees. And then grab the longitude, put it in the longitude, and all we have to do is click this button. Let's see how we did. Whoa! That is pretty darn accurate. I would say definitely very close to the actual center. If I actually do a measurement, it's almost, I'm down to pixels now at this point. Let's go ahead and do a quick measurement, planar measurement here between this point, that's the bottom of it right there, to there-ish. It's about 0.15 feet. So that is very, very close. About 1/10 of a foot is definitely good survey grade data. So this is the horizontal accuracy, right? This is just the horizontal distance between these 2 points. Now remember, this was not used as a ground control point. This is now used as a checkpoint. So we have 2 checkpoints in here. We have the Aeropoint, and we also have, now remember, we also have the other NGS point. Let's plot it. So here is the NGS point. Right here. Let's see how close we get to this point. Now, where do I get this data? Now, this data is going to come from back here. I'm going to have the data sheet for this. And now I have the position, NAT 83 2011. That's what matches. So I'm going to grab the latitude in degrees, minutes, seconds. Go back into ArcGIS Pro. Change this to degrees, minutes, seconds. And paste. And then I'm going to go get the longitude. Now remember, this is west, so it needs to be negative. Go back to the longitude. paste. I gotta go back to the beginning, hit negative, and let's do the same thing. Let's hit this point. Oh, very, very close. So once again, we're about a tenth of a foot off from the actual horizontal location for both points. So this is for the PPK map. If I turn the RTK map, you see there's more of a shift. Still pretty close, but it's not on the actual point. If I click this, I am pretty much almost right on. It's not exact, it's centimeters off. Centimeters off, 2-3 centimeters is sort of what we're expecting. This is a very high quality map. But there's one more step. Okay, so one thing that PPK and RTK technology does very, very well is it handles horizontal offsets very well. The one thing that it doesn't, so what it does is it corrects the images on the aircraft. Remember, we already talked about this. But now, what about vertical? So it may create a very precise horizontal approximation of the surface, but it's gonna have a vertical offset, even with PPK and RTK. So how do we fix that? And let's just show you how we do that. So let's use this, this particular point. DroneDeploy makes this pretty easy. If I go to map details, there's this button, this tool called Calibrate. This Calibrate actually lets me, if I click the center of this point, on or about, it lets me put a custom elevation here. It lets me do a vertical offset. Now, where do we get this number? So if I go back into this data set right here, I'm gonna use this NavD88 orthometric height. So I'm gonna copy this, and I'm going to hit paste, and I'm going to hit calibrate. Now all that's gonna do is the horizontal accuracy is gonna maintain the same. It's gonna get a vertical offset to the elevation data. Now let's check it. How close is this now? Remember, we have another checkpoint. So let's go to this other checkpoint. You can see that it's been vertically calibrated. Let's go to this other checkpoint for a minute, because we also have its NavD88 height as well. Now, keep in mind, on the day that I did this, there's a lot of vegetation here that I did not clear. I put the point on top of it. So there's probably about a half a foot difference between horizontally, it's exactly the same, but there's about a half a foot vertical difference between the point that I set, the surface that I make, and where the actual pin is. So let's check this height here. So here's the height here. Here's the NavD88 adjusted height. Here's the ortho height, same, right? NavD88 ortho height. We calibrated to NavD88 ortho height, 515.37. I'm expecting mine to be a little bit higher than that, maybe up to about a foot. So let's take a look. How do we check that in DroneDeploy? Okay, so let's go back. Let's place a point, a location marker, and it's gonna pull the location height from that marker. So here we go, 5116.21 versus 5115.37. So less than a foot difference. That actually checks with the fact that it was actually the pin was depressed almost a foot, I would say. It was an imprecise measurement, to be honest. Just full disclosure, it was a little bit of an imprecise measurement. I didn't clear the vegetation. I didn't put the ground control point material flush on the surface. There was just too much vegetation there and I didn't really want to clear it. So this actually checks. It's within a foot, vertical, horizontal, it's within centimeters. And this foot can be accounted for, or less than a foot can be accounted for by just the vegetation height at that area. So all in all, this particular map is now extremely accurate, both X, Y, and Z, within centimeters, within a tenth of a foot of all of them, based on the checks that we've made. So I feel very confident delivering this to a customer using PPK, and like I said, we did this now with one ground control point. All right, so that's it. That is how you use one ground control point to create survey grade data using the Mavic 3 Enterprise and an RTK network with PPK post-processing. So that is the whole workflow, beginning to end. If you have any questions, leave them down below in the comments. If you found this information valuable, please like, subscribe, share with your friends. If you have additional questions or you want to understand a workflow using this equipment, please let me know. If you have an alternate workflow, let us know down in the comments. So thank you so much for joining us today. Happy that you're here at the Do You Know Drones podcast, and we'll catch you next time. Bye now.